We saw that the accept method on the TCP listener returns a result. If for some reason the accept fails, we don't want to terminate our program. This is an example of a recoverable error. If one connection is unsuccessful, we should just try the next one. This means that we can't just call unwrap on the result of the accept. As we remember, unwrap will terminate the program if the result is an error. We have to check if the result was an error before we can unwrap it. To do that, first we can assign the result of accept to a variable. So let's create a variable, call it res for result. And now we can check if the result is an error by writing an if statement. If statements in Rust are very similar to the while loop that we saw. We just type if followed by some condition. In our case, we want to see if the result is an error. And if it is an error, there's nothing that we can do. We just have to jump to the next iteration of the loop. And here, after this if statement, we know that we actually have our stream. So here we can say that our TCP stream equals result.unwrap. Now we can safely call unwrap because we are completely sure that it will not terminate our process because the result is not an error. But unwrap here will actually return a tuple. As we remember, the accept returns the TCP stream and the client address. We can automatically assign the contents of a tuple to variables by using the tuple syntax. So if we follow our let with parentheses, and in here we can specify the variable names that we want for every element in the tuple. So we want our stream and we want our address. Now this will unwrap the tuple and assign its elements to these two variables. We see that stream is of type TCP stream and address is of type socket address. This code seems fine, but it's not the best way to handle enum variants in Rust. With result, it is simple because it only has two variants, OK or an error. But what if, for example, we had to check the variants of our method enum that has 9? Like if we wanted to have different logic for everyone, that would be a lot of if-else statements. And this would make the code unreadable. To make working with enums more powerful and convenient, Rust has a special control flow operator called match. It allows you to compare a value against a series of patterns and then execute code based on which pattern matches. We can match the result of our accept function. Let's try to implement this same code with the match expression here. So we use the match keyword and then this is followed by the value that we want to match on. So we can follow it directly with the results from our accept, and then we open up the body of the match. Important thing to mention about matching on enums is that the code will not compile unless we have covered all the possible variants. So in this case, we are not matching anything, we're not checking if the result is OK or an error. And we see that the compiler complains because these two patterns, the OK and the error, are not covered. The compiler will make sure that we always cover every possible pattern from the enum that we're matching. So to match a specific pattern, we type the pattern. For example, we want to check if the result is OK. So we just type the OK and we follow that with an arrow. And this arrow is followed by a body of some code. So in here, we can do anything that we would like to handle the OK case. We can define a variable, we can print something. So for example, we can print line OK. And we can do the same for the error case. Separated by a comma, we can write another pattern. So if you want to match the error, Again, we follow that with an arrow, and if the code that we want to execute is a single statement, we can write it directly without the curly brackets. So for example, if we just want to print that we have an error, we can write it like that and omit the curly brackets. But now the compiler still complains. It complains because it expected one field but found 0. What that means is that in the result, as we know, the OK variant actually wraps a value. In this case, the OK will wrap the tuple with the TCP stream and the socket address, but we are not handling that at all in our match expression. When matching on enum variants, we can bind their values. We just have to specify a name, like a variable name here, and this value will be assigned to that. So if we just type tup, now the resulting tuple is assigned to that. And we can see that we have our TCP stream and our socket address. Cool thing for match expressions is that we can use the same syntax that we used with our let down here to actually extract values from the tuple. So for example, in here, we can just say that we want our stream and our address. And now the tuple is exported for us. Now we can use the TCP stream and the client address in the scope of this match expression. We see that we have the same error for the error case because it also wraps an error object. So we can actually get the error object like this. Let's call it E for error, and we can actually print it to the screen. So if we fail to establish a connection, we can say fail to establish a connection, and then we can print the error. Now we have handled both cases for the result from accept. But what if we don't want to use the result in the OK, for example? If we want to ignore some value that variant wraps, we can substitute that with an underscore. And now the pattern is still valid because we acknowledge that the OK wraps some value, but with passing an underscore, we tell the compiler that we don't care what this value is. We don't plan to use it and we want to ignore it. In our case though, we would like to actually use our TCP stream, but we don't really care about the address. So we can only substitute the address here with an underscore. So now only this part of the tuple will be ignored, but we still get our TCP stream and we can use it in the body of our match. We can also use the underscore as a pattern. Imagine that we don't care about the error case. If we just put an underscore as a pattern here, this will act as a catch-all pattern that will catch all the variants that we have not matched manually. In this case, it will catch the error, but if it's an enum with more variants, it will catch all of the variants that are not matched explicitly. This is similar to the default case in a switch statement in other languages. But we would like to actually log our error, so let's return our code, and we can get rid of all of the code here because we would like to use our match statement. One last thing about match. Match does not work only on enums. It can also be used as a regular switch statement. For example, we can match on a string. If we just match the string ABCD, like this obviously would be some variable, and we can see if it is this string, then print line something. If it is some other string, then do something else, and we can also have a default case that will do something else. Another thing that we can do in match arms is we can pass multiple patterns using the pipe symbol, and now it will actually match against this pattern or this pattern. Okay, let's get rid of all of that. And you can see that now our code is much nicer. It is very clear that we have two cases. If an error happens, we just print it to the screen, and everything in the body of our match expression is what happens when we had a successful connection.